Thank you very much. Can you hear me? Okay, so, okay. First of all, I'd like to appreciate to have an opportunity of presentation in this conference. My name is Koji Kawamura. I'm from Kogyo, Japan. Today, I'd like to talk about simplified gas detection and gas sampling method. Okay, this is background. So we analyze gas for various purposes, such as industrial process control, industrial hygiene, environmental monitoring, and forensic science. We sample the gas with these devices, such as gas bag, gas solvent tube, and air sampling pumps. After sampling, we analyze with costly analytical instruments, such as GC and HPLC. However, skill is required to use these devices. So we developed the various gas detectors, simplified gas detectors such as gas detector tubes and total VOC detectors and wearable and IoT gas detector. This simplified method is a powerful tool. However, it's not perfect. So if there is an influence of coexistence gas, we should use separation analysis. So we developed the simplified gas sampling method for separation analysis, such as small air samplers and the direct syringe disruption method and inflating gas bag. We have developed for easy to use and inexpensive method for field operation. First, I'd like to explain simplified gas detector. This is gas detector tube. Gas detector tube is a glass tube that fills chemical reagent. This is how to use. Cut the both ends, insert the gas pumps, and pull the handle of manually aspirating pumps. One stroke is 100 milliliters. After 1 or 2 minutes, the color of detector tube is changed like this. Top of the stain length is indicate concentration. This is a single-use product. For lower concentrations, we use electrical aspirating pumps. We have many detector tubes for more than 200 types of gases. These are examples of the principle of gas detector tubes. We use pH reagent for acid and alkaline gas detection. The color of pH reagent is changed like this to react with gas. We use chromium oxide for hydrocarbon and alcohol detection. We use mercury chloride for phosphine, mercaptans, hydrogen sulfide, and hydrogen cyanide. We also use lead acetate for hydrogen sulfide detection. We also use hydroxyamine for aldehyde and ketone detection. And we use polymerization reactions with sulfuric acid for detecting of aldehyde and styrene. This yellow product is a polymerization product of styrene. We use iodine pentoxide for aromatic hydrocarbons such as toluene and xylene. We also use oxidizer in tube. Halogenated hydrocarbon is oxidized and HCl is generated. This HCl changes the color of the pH reagent in tube like this. We also use dye for ozone detection, and we use magnesium chlorate to detect the water vapor. Okay, this is the history of gas detector tube. The first gas detector tube was invented by Lam and Hoover in US in 1918. But this tube was only used for qualitative detection. Quantitative measurement was not yet possible. So Dr. Kitagawa developed a quantify hydrogen gas detector tubes from stain length in 1946, and he was president of our company. So he controls the amount of and flow rate of gas in the tubes. This method is very good. Without electrical power source, simple to use, 1 or 2 minutes for measurement, small, lightweight, portable for field operations, pre-calibrated. It means no calibration on the user side. In Japan, detector tube is used as the official method for various fields, such as working environmental modeling. We improved gas sensitivity of gas detectors for ultra-low concentrations. The sensitivity is improved by increasing the volume of sampling being drawn, with such as these are electrical pumps. And we improved sensitivity has been developed by increasing the surface area of reagent carrier with colloidal seeker. By this method, we developed formaldehyde, ammonia, formic acid, acetic acid detector tubes for less than 0.1 ppm. These tubes are used for indoor air quality, clean room, and museum, and so on. We also improved the selectivities of gas detector tubes with selective gas removing reagents. These are examples of gas removing reagents. For instance, this is CO remover, hopcalite. This catalyst oxidizes carbon monoxide to carbon dioxide. We can develop the highly selectivity detector tube with this reagent. Okay, next, recent research. We use heavy metal for gas detector tubes, such as mercury, chromium, and lead. But however, this compound is toxic and regulated in many countries. So we developed a novel gas detector tubes without heavy metal for environmental load reduction. This is the mercury-free gas detector tubes for H2S and mercaptans. We choose silver toluene sulfonates instead of mercury chloride. And for phosphine tubes, we choose silver sulfate instead of mercury chloride. And by these reactions, brown product is generated like this. We use mercury-free gas detector tubes with this principle. We also developed a non-chromium gas detector tubes for alcohol. This is a conventional detector tubes for alcohol with chromium oxide. We choose potassium manganate instead of chromiums. The color of detector tubes will change from purple to white, like to react with ethanol. This is the calibration line for ethanol. This detector tubes can detect not only ethanol, but also methanol and isopropyl alcohol. We have developed a novel detector tubes for alcohols without chromium oxide for eco-friendly. We got the poster award in the International Conference of RSC. Next is crime investigation tubes for fire. With iodine pentoxide, original color of detector tube is white. In case of gasoline, the color of detector tube changes to yellow and greenish brown. In case of kerosene, detector tube is changed to brown and pale brown. This tube is used by police and firefighter in Japan for crime investigation. Okay, next is the total VOC detection method. To detect TVOC is very difficult for simplified gas detector, but this method is possible to measure the TVOC as the amount of carbon dioxide unit of the ppmc. All of VOC is in sample gas was oxidized to carbon dioxide with heated catalyst, and the generated carbon dioxide was detected with CO2 detector tubes. These are sensitivity of this method for various VOC and mixed VOC. Sensitivity is within plus minus 10% of 100%. Okay, next is gas sensor, electrochemical gas sensors, a CO, wearable gas sensor helmet mounted to CO gas detector tube system, a gas detector system. In case of waste alarms, you may not notice because the factory is a noisy place. So we put on the light, sound, and vibration in front of your eyes. You will not miss the alarms by this product. This is our new product. We also developed IoT monitoring systems, and this is oxygen sensors. This sensor sends the result to internet through the gateways. We use AWS and Zabbix for data server and monitoring system to reduce the cost for IoT because these software are open source. So we can check the results of sensors with each smartphone and PC. These are examples of oxygen monitors. If sensor detects oxygen deficiencies, gateway sends the email to smartphone as an alert. Okay, next is the simplified gas sampling method. This is conventional method, and we collect the VOC with solvent tube, charcoal tube, and silicon tube, and pumps. However, conventional pump is so big, heavy, noisy, vibrate. It's not good for workers. So we developed a new air sampler, small and light, silent, without diaphragm, vibration free. We choose the novel principle of piezoelectric effects. This pump is very small and no vibration, no sound. So we could make very small pumps compared to conventional pumps. These are size and weight of pumps. Okay, this is a field. We have field experiment for analyze the tetrahydrofuran, and workers collect the air with conventional sampler and our new samplers simultaneously. This is our samplers result. This is conventional samplers results. And measurement results of developed sampler is almost the same of conventional sampler. Developed sampler is smaller and lighter than conventional sampler and does not get in the way of doing the job for workers. Okay, next is sampler for gas bag samplings. For gas bag samplings, we use these containers. Air in container is evacuated with air aspirating pumps. Because sample gas passes through the pump is not good because VOC reacts with the inner side of a pump. So we developed the pumps for gas sampling without absorption VOC in the pumps. We adapted a new principle by quartz crystal units that does not use a diaphragm as a principle. Gas can be collected directly into the gas bag through the pump. Okay, this is conventional method. Very big container, big pumps, and gas bag. It's complicated. However, this is our method. Very nice small pump and only gas bag, only easy to use. This is a field test for ethyl acetate. This is the time course of sampling. This is the concentration. And red point shows conventional method, blue point shows our method, and both result is almost the same. And this is another test for acetones. There is no difference, almost no difference in measure value and between the conventional method and our method. Okay, next is a needle to collect the VOC. It was called Needle X. Needle X is developed by Dr. Saito and Shinwa Chemical Industries. It's a company. We have a relationship with them, so we have an experiment for gas sampling. This is conventional method. We collect the VOC in solvent tube and break tubes, and charcoal is put into the solvents. This method is not easy, and moreover, this solvent is toxic solution. The other method is thermal desorption method, but this device is very expensive, so there is no easy and inexpensive method. Gas back method is easy. However, concentration is decreasing after sampling within 2 hours. This is principle needle X, and there is a adsorbent particle in needles. Pull the handle or plunger of pump or syringe, VOC is correct in needle. And VOC in needle is dissolved by the heat of the injection port of gas chromatography. Easy to use, no special device, no solvents. And needle X can concentrate to the VOC easily. If sampling volume is 100 milliliters and desorption volume is 1 milliliters, VOC is concentrated to 100 times. This is an example of concentration by needle X. Red line shows without needle X. Blue line shows with needle X. Each peak of VOC is increased by needle X. Okay, this is the result of ethanol from breath after drinking beer. This is the time after drinking. This is the ethanol concentration. This is the result of gas tight syringe, and this is the result of needle X. Blue line shows after drinking beer. Like this, result is almost the same, and from this result, we confirm that needle X can detect the alcohol in breath. Of course, gas tight syringes cannot keep the ethanol in needle, but needle X can keep the ethanol in needles for 7 days. It is good for transportation to the laboratory. Needle X will help your measurement for alcohol in field operation. We also tests for 1,2-dichloropropan. 1,2-dichloropropan is carcinogenic material and cause of urinary tract cancer. And this is a result of gas tight syringe and needle X. Both is almost the same. And these are calibration lines for dichloropropan for lower concentration and high concentrations. From this result, we believe needle X can detect the 1,2-dichloropropan. And needle X can keeps 1,2-dichloropropan in needle for 10 days, and it was concentrated 1,2-dichloropropan for lower concentrations. So needle X can be used to detect the 1,2-dichloropropan for industrial hygiene. Okay, this is a manual inflating gas bags, and to put just gas bags, sample is collected into the gas bag like this. This product is invented by Nextech LLC. It's an American company. We collaborate with them, and we have an experiment about gas samplings. The retention rate of various gas concentration in the bags at several hours after sampling. This is ethanol, hydrogen sulfide, hydrogen cyanide. And the blue line shows our method. Red line shows our conventional drug gas bags. The manual inflated gas bag is usable as a device for emergency gas samplings against accident and terrorism caused with explosive and toxic gases. Okay, this is conclusion. We have developed various simple gas detectors, such as gas detector tubes for eco-friendly products, chromium mercury-free detector for forensic science, and TVOC monitor, wearable, and IoT sensing monitors. And we also developed gas sampling methods, such as small, no vibration, no sound sampler, no container required samplers, and needle extraction needles for VOC, and manually inflating gas bag. We hope to build a safe and secure society with gas measurement. We will continue research to establish the system that anyone can easily measure the environmental on field. That's all. Thank you very much.
Thank